Alrighty, so today we have a tropical storm rolling through, so I thought it'd be a perfect time to bring out the whiteboard. This will be going in both the welding playlist and the history playlist, because I'll be throwing some history stuff in here too, because it makes it more interesting in my opinion, but it also goes over welding. So, best of both worlds. So, our heat affected zone, we're gonna just pretend we have our parent metal here. Best drawn, but it will suffice. So we have our parent metal. It's two prepared pieces of steel. We have just mild steel for this scenario, like what most welders will be going through. We have our root face and we have our landing. I'm not going through any specific dimensions. This is just an example. And so just say we get our weld going through, we'll have our weld in here, and it doesn't matter. We can have melt through or a backup weld. Just do a backup weld. It's fine. And we have our different beads going in. But what this does to the parent metal as you're welding is in this area, part of the parent metal, it will be deteriorating the parent metal. It will not be as strong as it is over here. It will be the heat affected zone. The welds will go up and you'll have your coverage over your points. And this part right here will be weaker than any other part of the metal as long as there's no given blemishes in the parent metal already that are unaccounted for. So you'll have your regular steel over here. It's just like it came from the mill. Right here we'll have our welds. Our welds will be super strong. That's what welds are. They're very strong. The downfall, though, is this area, the heat affected zone, because there's so much heat going in here and it'll be cooling out, it'll be just deteriorating the strength of that zone. The size of the zone will vary depending on how many welds are going in, how much heat's going in. And this is interesting. This can be compared and demonstrated by American armor during World War II versus German armor. And what I mean by that is German tanks. Germany invested a lot of money in their industrial plants before the war. So we'll have our very crude drawing of a turret. It's not going to be exact by any means. Wow, ain't that pretty? It's hideous, but just say this is a German tank's turret looking from the top down. It will be rolled. So I don't know this for a fact, but we'll say this is all one piece of steel and it's maybe welded in the back, fused in the back, however they got it together in the back. Whereas an American tank, it may have had some round edges, it may have had some flat edges, whichever style. But as we had our weld here, they will have welded together their armor in any given amount of spots that they needed to. So I'm making up the amount of welds. I didn't look up how many welds they put in or where exactly they're put in, because various pieces of armor had various pieces going into it, various construction methods. We did not have the industrial plants to have rolled steel as the Germans did. So what this did, if we put in welds in each one of these spots that are just like this, then on each side we're going to have a heat affected zone. So on each side of our welds we'll have heat affected zones. So yes, we will have our parent metal in between, be more precise, in between these points, which will be this right here. It's going to be their armored steel and it'll be perfectly fine. The welds are going to be extra strong. That's what welds are. But we're going to have these brittle spots in comparison to our parent metal and our welds. And they're going to be on each side of the welds. So if you have projectiles coming in or various pieces of ordnance hitting, scraping these areas, it's more likely to go through and to bust that area. So we had a high output compared to the German war effort because we were able to weld. It's a lot faster and a lot more cost effective to weld. But rolled steel is much more effective at defeating ordnances that are aimed at it and impacting it. Just find this very interesting because it plays into learning about welding, and it's also really cool because it has history in it. Best of both worlds. I've done inspections on various mechanized armored vehicles from pieces from the 80s. I've gone to various locations, also inspected, not quite World War I. Those were more bolted together. If you look at World War II, especially later World War II, you see a lot more welded American armor. It's very interesting to see the welds. Even on modern armor, sometimes they're not the best welds, which is unfortunate. So not only do you have these heat affected zones, but there will be welds that don't even give full coverage. They will leave these pieces exposed, which is a good indication. Let me use a different color to draw arrows. These points, because they're not called for by the WPS, you can have cracking in there, especially if you have ordnance impacting that spot. That's going to really affect your heat affected zone. And so you'll want, like any other weld, you want it covering those corners. If you don't cover that, it's not structurally sound. They should be inspected. Some slip by. So I've liked the welds that I've seen when I've been in Oshkosh vehicles. I don't know the exact name of the vehicles. It's the newer ones. They're mine resistant. I forget the abbreviation. Not an MRAP, but it's similar. And I've liked the welds on there. The ones that I've inspected from more the 80s, their welds are hideous. No lie. You'll have, just say we're doing a top view here, and the weld will be going back and forth, covering like it's supposed to, and then it'll just completely skip a spot. And it'll skip another spot, and it's not even covering everything. There'll be things left and right. There'll be little pits. Even when it's covered in paint, it will show through that there'll be a huge spot here, spot there. It's not even covering all the way over here. It's quite sad. And it was a mechanized vehicle. It was armored. It was armored steel. And it was just horrendous, the welds on it. And it was actually in service. I don't know how it passed inspection, but yeah, no. The welds that I've done on armored plate for armored robots and whatnot, that took a good amount of time because some of the WPSs for it would be calling for it to be preheated and post-heated. So preheat is if you have your parent metal here, no welds, you're getting ready to weld, you have to heat it up so that it's not all this intense heat coming at once. You want to slowly heat it up so it's a warmer temperature. It depends on what the sheet calls for. It could be 150 degrees, it could be 450 degrees, whatever the WPS calls for on whatever project you're working on. The preheat would have it heated up, would do the welds, get done, and then we'd do a post heat. So we'd put heat back on it quite quickly. So it's almost immediately after the welds are done. We're heating it up. If it needed to be on both sides, we'd do that, or just on the top side. And we'd slowly decrease the heat over a certain period of time, whatever it was called for, because that will get this heat affected zone to be mitigated. So instead of going all the way out to here with all this intense heat going into this brittle AR500 steel or a different kind of tempered steel, we will have a smaller, less affected heat affected zone. Now, if any of the welders out there are a little bit confused about this, if you think about cast iron and welding that, you can kind of relate it to that instance. When you're welding cast iron, some people say it's impossible to. it is possible. It's extremely difficult. It would be you preheat the cast iron, you get the welds in. Odds are they won't be the prettiest. Sometimes you can get them be decent looking. And then if you're not doing a post heat, a lot of times you have to put your welded project in a container of sand. So if you're doing a large project, you have to put a lot of sand. You have to be putting a lot of, I forget the name of the blankets, but you put on there so it reflects the heat back in. It keeps the heat in here. Special blankets, but sand is used a lot of the time on cast iron, and it's just packed on it so the heat stays in this area and slowly decreases over time. And I'm not talking days or weeks or anything, hours, most likely less than hours, plural. You have it there for an hour. It depends on what the project is. It's similar to that. But I always thought it's pretty cool. Loved history and loved welding. So, yeah, that'd be the heat affected zone right there, and the difference between American and German armor, and why ours was weaker at these points, among several other design reasons. But yeah, thought y'all might like that. So let me know in the comments what you think of it. I'm hoping to do some more of these whiteboard, different demonstrations, if we want to put it that way. So it's going to be math, blueprints, explanations such as this. So, alrighty, hope y'all enjoyed that. We'll see you in the next one.